Hello, welcome back to my channel. In today's video, we will discuss regression modeling. Let's get started. First, what is regression? Regression is a supervised learning technique which helps in finding the correlation between variables and enables us to predict the continuous output variable based on the one or more predictor variables. It is mainly used for prediction, forecasting, time series modeling, and determining the causal effect relationship between variables. A regression model provides a function that describes the relationship between one or more independent variables and a response dependent or target variable. For example, the relationship between height and weight may be described by linear regression model. A regression analysis is the basis for many types of prediction and for determining the effects on target variables. When you hear about studies on the news that talk about fuel efficiency or the cause of pollution or the effects of screen time on learning, there is often a regression model being used to support their claims. Some example of regression can be as prediction of rain using temperature and other factors, determining market trends, prediction of road accidents due to rush driving. Types of regression, linear. A linear regression is a model where the relationship between inputs and output is a straight line. This is the easier to conceptualize and even observe in the real world. Second, a multiple. Multiple regression indicates that there are often more than one input variables that may affect the outcomes or target variable. Third, nonlinear. A nonlinear, a linear model may work for some parts of the marketing. However, we know that as we keep increasing the number of emails in a particular campaign, the number of response starts to decline versus the number of emails sent. To model these, we need a non-linear regression model. Fourth, stepwise regression model. The stepwise regression model we will discuss in detail. Why do we use regression analysis? The regression analysis helps in the prediction of a continuous variable. Some other reasons for using regression analysis are is regression estimates the relationship between the target and the independent variable. It is used to find the trends in data. It helps to predict real continuous values by performing the regression. We can confidently determine the most important factor, the least important factor, and how each one is affecting the other factors. There are many benefits to being able to establish a statistical significant correlation between important business outcomes. By doing so, you may be able to make important business decisions based on indicators. Our example is any correlation you can establish between GDP, consumer confidence, or industry benchmarks and your own business, which may help with investing or strategizing. Another valuable example would be if a relationship can be established between business decisions and outcomes. These decisions can be better tuned for optimal results. For example, the price of a product and the number of sales is often correlated and can be modeled using regression modeling. So this is the example of regression modeling where we can use regression modeling. Now, estimation model evaluation. The goal of estimation model evaluation is to measure the performance of a regression model in predicting continuous outcomes, ensuring its accuracy and reliability. Evaluation metrics. Key metrics to evaluate a regression model include mean absolute error, measure the average magnitude of errors in predictions, ignoring their direction. Smaller AMAE values indicate better model performance. Mean squared error MSE penalize larger errors more heavily by squaring the differences. Root mean squared error, the square root of MSE, giving errors in the same units as the target variable. Standard error of estimate reflects the typical size of residuals R square. Coefficient of determination indicates the proportion of variance in the target variable explained by the predictors. Steps in evaluation: split data, divide the dataset into training and testing subset. For example, 70% training, 30% testing. Train the model, fit a regression model to the training dataset. Make predictions. Use the trained model to predict values for the testing dataset. Calculate metrics. Compare predicted values against actual values using metrics like MAE, MSE, RMSE, and R square. This is the code of estimation regression modeling. First, we import few libraries. This is the sample data set. Here we create two variables. One is independent and second is dependent variable. Here we train the data set. Here we using regression modeling. Here we evaluate the data. We execute the program to see the output. This is the output of AMAE. AMAE equals to 0.28214228. MSE equals to 0.1077806. RMSE 0.32829999. R square equals to 0.987184. Now, stepwise regression. The stepwise regression is a feature selection technique used to iteratively add or prediction, remove predictors from a regression model based on their statistical significance. While the other items we have talked about until now are specific types of models, stepwise regression is more of a technique. If a model involves many potential inputs, the analyst may start with the most directly correlated input variables to build a model. Once that is accomplished, the next step is to make the model more accurate. To do that, additional input variable can be added to the model one at a time in order of significance of the result. Using our email marketing example, the initial model may be based on just the number of emails sent. Then we would add something like the average age of email recipient. After that, we would add the average number of emails each recipient has received from us. Each additional variable would add a small amount of additional accuracy to the model. This process is a stepwise modeling approach to getting the most accurate model. Alternatively, the analyst may start with the larger set of input variables and then incrementally remove the least significant in order to get to a desired model. Types of stepwise regression: forward selection. Start with no predictors. Add variables one at a time based on statistical significance. Example, lowest p-value or AIC. Backward elimination: start with all variables, remove at least significant variable at each step. Bidirectional elimination: combines forward selection and backward elimination. Stepwise regression is particularly useful when working with data sets containing many predictors, helping to reduce overfitting by removing irrelevant variables, simply models for interpretability. Thank you for watching. If you have any doubt, please comment it down below. Don't forget to like, subscribe, and share.